So you can see what this demands. It demands the complete rejection of the idea that a given gene is identifiable with a given trait. That you can say this gene right here on the chromosome, right in this spot, it is for that thing that we see it affecting. Now, that has to be abandoned. Now we are in a very different world in which a given gene can have an impact on multiple different traits, and conversely, and not the same thing, that a given trait is affected by multiple genes. So with that concept kind of hovering there, let's take a look at what we can say. How are genes related to the processes of development and thereby indirectly to the production of traits? It's called a cascade. The idea is that for a given spot on the body, let's take a look at that early embryo and identify a spot which later we can talk about as its elbow. And what you will find is that different genes are, if you will, activating in the cells at that spot at different times. And so if you want to, you could make a diagram. You can make a list of the most important genes that operate in that spot one after the other. And each one's activity is occurring in the environment produced by the prior activity. And therefore, the gene itself is not mystically generating an effect of its own. Instead, it is entirely contingent on what has happened in that spot already. That's why we call it a cascade. You can think of it as one gene, one gene, one gene, one gene, which even in itself is a little simplistic, but the idea being of a sequence of effects in that spot. These cascades are themselves adjustable. These are genetic effects, each one with a genetic variation. And so you end up with an understanding of variation that's extremely different from the old school, well, you have one gene and then you have different combinations of alleles, and that's where your variation comes from in that trait because that gene makes that trait. 100 years ago, people were talking about how many genes must be involved in an organism such as ourselves. And clearly it was in the millions. There must be millions of genes. After all, look at all the traits. Look at all the crazy things that happen around our body. How can this not be carried out by millions of genes? Throughout the 20th century, with more and more understanding of the molecular features of genes, that number dropped and dropped and dropped. By the time I was teaching in the 1990s, we were telling students that the estimate was 100,000 genes for a creature such as ourselves. That was quickly curtailed by the completion of the Human Genome Project in 2003, and all of a sudden we said, whoa, not 100,000 genes like I just told you last quarter. No, more like 25,000 to 30,000 genes for a mammal. And even that estimate has been dropping a bit lately. So think about that. Let's say 25,000 genes. For all the stuff that goes on to make and be a mammal, how is that even possible? And the answer is, of course, now we understand that no trait is the effect of a single gene. When we talk about a gene with massive penetrance upon a given trait, such as that attached or unattached earlobe, we're not saying that one gene is the only thing that makes the earlobe. We're saying that that gene has a disproportionate effect on the outcome of the cascade in that spot.